Hello everyone, let us try to solve this question, right? So it is saying that if the crank and the connecting rod are 300 and 1 meter long respectively, and the crank rotates at a constant speed of this 200 rpm, then determine the crank angle at which the maximum velocity occurs, right? Okay. And also we have to find out the maximum velocity of the piston. Okay. So what are the given data over here? Let me increase the thickness a little bit. So what are the given data? Here tank radius is given, that is r, that is equal to 300 mm. So for better conversion, let us convert this mm into meter. So I can write this is 0.3 meter. Okay, and L is also given to us, that is 1 meter. Okay, and the speed is given to us, that n, that is 200 rpm. Sorry, so this is given, this is rpm. Okay, and what we need to find out, so to find, we have to find out the value of crank angle, that is theta, at which the velocity is maximum, right? So we need to find out the theta for which velocity will be maximum and the maximum velocity. Okay, so first of all you have to find out the value of theta for which your velocity is going to maximum. Okay, so we have this particular relation with us, we know this relation, that is the velocity of the piston, that will be equal to r times omega sine theta plus sine 2 theta divided by 2n. Okay, and if it is asked to find out the maximum velocity and the theta for the maximum velocity, in that case we have to differentiate this velocity with respect to 0, right? So sorry, we have to differentiate this velocity with respect to theta and we have to equate it to 0, right? So if we will be doing so, I can write dv by d theta, so that I can write, so r omega, this is the constant term, so it will be remaining as it is, and the differentiation of sine theta with respect to theta, that I can write cos theta over here, plus here sine 2 theta, so this will be 2 uh, let me, okay, this will be 2 cos 2 theta divided by 2n. Okay, so from here this can be deducted. Okay, and this is the dB by d theta we got over here, and we have to equate this to 0, right? So equate करना है 0 के साथ, so we'll be doing, and this is, okay, and from here we can find out the value of theta. Okay, because we know n. Okay, so we can find out the value of n over here. Okay, so n will be equal to what? L by r. Okay, so n, L value is given to us as 1 meter and the r value which is given to us as 0.3. So it will be doing this particular calculation, we can find out the value of n as 3.33. Okay, so n value we know, and here the unknown is only theta, so we can find out the value of theta. Okay, so we can do one thing, so here n is there, so we can do some calculation, right? So we can take this r omega term to the right hand side and simply we can equate, we can solve this. I can write n cos theta plus cos 2 theta divided by n, that will be equal to 0. Again this can be taken to the right hand side and I can write n cos theta plus cos 2 theta, that will be equal to 0. And from the trigonometric relation we know cos 2 theta can be written uh, like this. Okay, so n cos theta, sorry, cos theta plus, so cos 2 theta can be written like 2 cos square theta minus 1, so this can be written like this and that will be equal to 0. Okay, so it will be arranging this term, then I can write this is 2 cos square theta plus n cos theta. So n here we have got the value, that is 3.33 cos theta minus 1, so this will be equal to 0. Okay, so here we got a quadratic equation. Okay, so if we be solving this particular quadratic equation, we'll be getting the value of theta, right? So let us try to find out. Okay, so it is in the form of this one, right? Ax square plus bx plus c, that is equal to 0. Okay, so we know how to solve a quadratic equation, so simply we'll be solving the quadratic equation, and we'll be trying to find out the value of theta over here, right? Okay, so let us try to solve it. So here cos theta, that will be equal to minus b. So b is here 3.33. So minus 3.33 plus or minus b square, that is 3.33 square minus 4ac, that is 4 times a. So a is 2 over here and c is minus 1. Okay, and square root of that divided by 2 times a, so that is 2. Okay, so after solving this, we'll be finding the value of cos theta. Let if I'm taking the only the positive sign, then I'll be getting cos theta as 0.26. Okay, so this value I'll be getting if I'll be taking the positive sign, and this is the value of cos theta, right? And if I'll be finding the value of theta from here, then I'll be getting as 75 degree, and this will be the first answer. Okay, so as this value of theta will be getting the maximum velocity. Okay, so next question it is asking to find out the maximum velocity. Okay, so for finding the value of maximum velocity, what we need to do, simply we have to put the value of theta in the equation of velocity. So b is equal to what? R omega sine theta plus sine 2 theta divided by 2n, right? So this is the formula, and from it already we have found out all things, but here we have to put the value of omega, right? But we are given with the value of n. Okay, so we have to find out the value of omega over here. So omega will be equal to what? Omega will be equal to 2 pi n divided by 60, right? So 2 pi n, so n is given to us as 200 divided by 60. So we'll be getting this value as, let me check, that is 20.95. So 20.95 radian per second. So this will be the value of omega. So this value we can directly put in this relation. Can put all these values in this particular equation. Okay, so let us put, and r is given to us as 300 mm, or that is 0.3 meter. So 0.3 times your omega that recently we got, that is 20.95. Okay, times sine theta, so sine 75. So this is the theta value we got for the maximum velocity. So we'll be putting that particular value over here, and here sine 2 times 75. Okay, divided by 2 times, so n value we got, that is as 3.33, right? 3.33. So after solving this particular equation, we'll be getting the value of b as 6.54 meter per second, right? So this will be the answer for this question, right? Hope you understood how to solve this type of question. So try to solve some more questions related to this. Okay.